What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. Switches. These are critical components of modern networks. They are responsible for efficient data forwarding and segmentation. And the CompTIA Network Plus exam emphasizes understanding and configuring essential switching technologies and features. And in this video, we're going to explore VLANs, interface configurations, 802.1q tagging, link aggregation, spanning tree protocols, and much more. All right, so let's begin with talking about virtual local area networks, or VLANs. So a VLAN, this is a logical segmentation of a physical switch into multiple broadcast domains. VLANs, they enhance security, improve network efficiency, and they reduce congestion by grouping devices logically rather than physically. All right, so let's talk about a VLAN database. So the VLAN database, this is where VLAN configurations are stored on a switch. And in some switch operating systems, VLANs are managed using the VLAN.dat file, which is stored in its flash memory. On Cisco devices, VLANs are created and stored in the VLAN database using commands like the ones you see on your screen right here. However, modern Cisco iOS switches, they allow VLAN creation in global configuration mode, as you can see on your screen right down here. All right, so let's move on and talk about a switch virtual interface. So an SVI, this is a logical layer 3 interface on a switch that allows inter-VLAN communication. And SVIs, they are essential for routing between VLANs and layer 3 switches. Now, to configure an SVI on a Cisco switch, you would simply type in some commands on your screen that look like this right here. All right, so let's move on and talk about interface configurations. And we're going to start with the native VLAN. So the native VLAN, this is an untagged VLAN that is assigned to a trunk port, and by default, VLAN 1 is the native VLAN on Cisco switches, but best practice is to assign a different VLAN to prevent VLAN hopping attacks. And if you want to change the native VLAN, you would type in some commands that look like this right here. And then we have what is called a voice VLAN. And this is a separate VLAN that is dedicated to voice over IP traffic to ensure quality of service. And if you want to configure a voice VLAN, you would type in commands that look like this right here. Next, we have what is called 802.1q tagging, and this is an IEEE standard for VLAN tagging, which allows multiple VLANs to traverse a single trunk link by adding a VLAN identifier in the Ethernet frame. And to configure an interface as a trunk and enable 802.1q tagging, you would type in some commands that look like this right here. And then we have what is called link aggregation. So link aggregation, this groups multiple physical links into a single logical link to increase bandwidth and redundancy. And the IEEE standard for link aggregation is 802.3AD, or LACP, which stands for Link Aggregation Control Protocol. And if you want to configure the LACP, you would type in commands that look like this right here. And moving on, let's talk about speed and duplex settings. So interface speed and duplex settings, they must match to avoid network issues such as collisions and slow performance. And some common speeds are 10 megabits per second, 100 megabits, 1 gigabit per second, and 10 gigabit per second. Then within duplex modes, we have two types. You have what is called half duplex, and this is used in legacy systems and shared media networks. And then you have what is called a full duplex mode, and this is used in modern switch networks. And to configure them manually, you would type in commands that look like this right here. All right, so let's move on and talk about the spanning tree protocol. So spanning tree protocol, this prevents layer 2 loops by disabling redundant paths in a switch network. And some variants include the following. So you have what is called RSTP, or rapid STP, and this is for faster convergence. You have what is called MSTP, or multiple STP, and this is for multiple VLANs. And you have what is called PVST plus, or per VLAN spanning tree plus, and this is for VLAN specific STP. And once again, if you want to enable STP on a switch, you would type in a command that looks like this right here. All right, so let's move on and talk about maximum transmission units or MTUs. So, MTU, this defines the maximum size of an Ethernet frame, and the default MTU is 1500 bytes, but it can be increased for performance gains. And if you do so, they're going to be called jumbo frames. So, jumbo frames, they allow for Ethernet frames that are larger than 1500 bytes, usually up to 9000 bytes, to enhance network performance in high bandwidth environments. And if you want to enable jumbo frames on a switch, you would type in a command that looks like this right here. All right, so that was a quick class. So, in conclusion, understanding and configuring switching technologies, this is vital for optimizing network performance and security. VLANs, they segment traffic. SVIs, they enable inter-VLAN routing. 802.1q, this provides VLAN tagging. And link aggregation, this boosts bandwidth. Additionally, spanning tree protocol, this ensures loop-free topologies. And MTU settings, they optimize data transmission. So, mastering these concepts is crucial for passing the CompTIA Network Plus exam and excelling in real-world networking scenarios. Now, to make the most out of all this knowledge, you're going to want to do some hands-on type of activities, whether you got access to a physical switch that you can configure, or you can download a program like Packet Tracer, or you can buy some type of virtual lab program that will allow for you to get in there and start manually configuring these things. That is the best way that you are going to learn and comprehend what all this information means that I just went over in this slideshow. Now, with that being said, let's do some check on learning. So the first question is, which of the following is a primary function of 802.1q in VLAN configuration? Is it assigns a specific IP address to each VLAN? Is it enables multiple VLANs to share a single physical switch port? Is it restricts VLAN traffic to specific interfaces? Or is it automatically assigns devices to VLANs based on MAC addresses? And the correct answer is it enables multiple VLANs to share a single physical switch port. So 802.1q, this is a VLAN tagging protocol that allows multiple VLANs to share a single physical port by adding a tag to Ethernet frames. And this tag identifies the VLAN to which the frame belongs, ensuring proper network segmentation across trunk links. Next question, which feature is used to prevent loops in a switched network by disabling redundant paths until needed? Would this be spanning tree protocol, link aggregation control protocol, native VLAN, or switch virtual interface? And the correct answer is this would be spanning tree protocol. So STP, this is designed to prevent switching loops in a network by identifying and disabling redundant paths. If a primary link fails, STP dynamically reactivates a redundant link to maintain network connectivity. And our final question, a network administrator wants to optimize traffic for voice over IP devices on a switch. Which VLAN configuration should be used? Would it be assign VoIP devices to the native VLAN? Would it be increase the MTU size for VoIP packets? Would it be disable 802.1q tagging for VoIP devices? Or would it be use a voice VLAN to prioritize VoIP traffic? And the correct answer is you would use a voice VLAN to prioritize VoIP traffic. So a voice VLAN, this is a dedicated VLAN designed to carry voice over IP traffic separately from data traffic. And this configuration prioritizes voice packets, ensuring lower latency and improved call quality by applying quality of service policies.